So this is the algorithm that we have for doing the chain rule. So let's use some examples with some explicit functions. We're going to find the derivatives here. So we have to follow these 6 steps. Follow these 6 steps, always going to profit. The first one is 2 times 5 minus 7x to the 5th. So what I'm going to do is I'm going to notice that this is a constant out front. So I don't actually have to do it this way, but I could. I could say that my g of x, sort of my inside function here, is 5 minus 7x. And my outside function is 2x to the 5th. So if I look at that, what I'm really saying is this is just some sort of blob here. That's 5 minus 7x. And the inside piece, I replace, instead of being what's in here, I replace it with just an x. So now that I have those 2 pieces, I have to find f prime of x. And that's 10x to the 4th because I bring the power down and then I subtract 1 from the power. Right? That's the general power rule. So the next piece is I need to plug g of x into f prime of x. So instead of an x here, I have a g of x. So that's 10, 5 minus 7x to the 4th. So 5 minus 7x to the 4th. Now, what I need to do is find g prime. Well, g is 5 minus 7x, so g prime is negative 7. And finally, I have to multiply what I get from here to what I get from there. So negative 7 times this is negative 70 times 5 minus 7x to the 4th. And that's how we get that particular answer. Our next one is 6t plus 10 to the 1/5 power. So we're going to follow a very similar process. We're going to say, all right, my inside function, the thing that's nested far in there, that's my g of t this time. Notice that we're doing this with respect to t this time, is 6t plus 10. And my outside function, something to the 1/5. So f of t is t to the 1/5. So next, I want to get f prime of t, and that's going to be 1/5 t to the negative 4/5. And then after that, I'm going to do f prime at g. So instead of a t here, I'm going to do g of t here. So f prime at g of t is 1/5 6t plus 10 to the negative 4/5. Then I've got to find g prime. So g prime, so that's g. So g prime of t is 6. And then I multiply these 2 things together to get 6/5, 6t plus 10 to the negative 4/5. So hopefully you're seeing kind of how this is rolling here. We're still going. Our next piece, we're going to follow the same algorithm, except we have s's here instead of t's or x's. So we have to use f and g of s. So the most inside thing is 3s squared plus 2. So what's left over? If I sort of turn that into a blob, what's left over is negative 2 square root of s, right? So that whole thing is just this blob right here. So then I take f prime at s, well, this is like s to the 1/2, right? So I could rewrite that as s to the 1/2. So that's -2 times 1/2 s to the -1/2, which is probably easier, more easily written as -1 over the square root of s, right? Because those cancel, leaving a -1. To the -1/2 turns it into a reciprocal, and that 1/2 power is the square root. So f prime at g of s, so again, you take this, and wherever you see an s, you plug in the whole part of g, 3s squared plus 2. At which point now we need to find what g prime is. So g prime of s is 6s, and then we multiply those together to get 6s over the square root of 3s squared plus 2. Sorry, those negatives have to stay on there. I knew something seemed off. And then finally we have this piece. So what might make more sense is you could do this with a quotient rule. That wouldn't be a problem at all. But it might be better to rewrite this as 4 times x minus 6 to the -1 power. And the reason we want to do that is because my inside function is now x minus 6. So everything that's left over, sort of my outside function, is 4x to the -1. So then I take the derivative of f. I bring the power down. I subtract 1 from the power, which is probably better written as -4 over x squared. And then I plug in g of x. So wherever I see an x here, I plug in this function. So -4 over x minus 6 squared. Then I find g prime of x. Well, g prime of x is just 1. So that tells me that when these are multiplied together, it's actually just this answer. So -4 over x minus 6 squared. And those are some simple examples of how to put the chain rule in practice. And we're going to do a few more just to really hammer this home.